What is up, guys? So I finally came to it, and this is a really big thing I really want to add to the 15-minute challenge of studying with Kendrick. So this is my microbiology book. So we are reading for my assignment this week. It's Microbiology Chapter 3, and I'm really excited to finally get to start on this book and show you guys how I'm going to study through it. And if you guys are interested in studying microbiology, you're in the right place, because we're all learning together. Microbiology is a big area of study, and I'm glad you guys came to watch this video. Now I'm going to begin this 15-minute challenge this first video of the 15-minute challenge series by skimming through the chapter. Yes, it's one of the most important things you gotta do when you first start reading. You gotta skim through the chapter. Look at big words like these, and then take note of it. Make sure to understand it, and when you come back and actually read through, maybe leave some dots and some paragraphs that actually look interesting and probably might be important for the lecture. So if you're in college and if you're probably getting into a health field, this is probably one of the classes you're most likely to take. So let's begin. Skimming through chapters. Small organisms with microscopes. Some important people that might be important to know, like von Leeuwenhoek, with the single lens. Another important thing in microbiology is people are also very important to remember. Learning objectives is a bit of a summary of what you're most likely to learn in the chapter, and you have a little bit of clinical case studies that are most likely important because it helps you visualize and use the material you're learning, so it's actually kind of helpful to read these things. And it looks like the clinical case for this chapter is going to be on microscopic mayhem. So it looks like a bit of bacterial disease that might be occurring here. Oh, it looks like we're measuring microorganisms with like this micrometer. Units measure it. Yeah, actually in the lecture there's lots of conversions that had to be done in order to see the bacteria better. We're going to be learning about microscopes. Von Leeuwenhoek, the guy who worked with the microscopes. Different conversions over here in this table that might be helpful. Parts of a microscope. Okay, you got your oculars, the body, you got the arm, objective. Your lenses are very important. The body tube, diaphragm. Your stage is your stage. Not a performance stage, but a stage for observing your specimen. Here's your base, here's your light, the light illuminates from there, and here's your knob, the part that adjusts your lighting. Light microscopy, that's the usual type of microscopes nowadays used to observe specimens. Yeah, it's magnification. Slime. What is that slime? Side anecdotes about help you grow in your interest of microbiology. Resolving power, resolution, details in the structure. Might be important. Yeah, I like to leave a little bit of dots in case I might want to come back there. Section 2, microorganisms and magnification. Microscopes. Light rays move in straight lines through a single medium. Fractal. Travel away from the specimen to achieve high magnification 1,000 times. You have to use the highest magnification to see things really well. A bit of how the microscope works. Light comes through. Oh, this oil immersion. So how this works is the oil allows the light not to be released or reflected and go out into the distance, because light is being absorbed, which means your image becomes less distorted. So using microscopes like these with oil immersion lens really helps you see images much better, in my opinion. Bright field illumination. Phase contrast microscopy. Contrasts make things more sharply defined, so you'll be able to see your microorganism better. We're learning about different kinds of microscopes. You have fluorescence microscopy here. Uses fluorescence to absorb short wavelengths, to understand different types of microscopes and see specimens in different ways. So, as you can see, microscopes aren't always perfect, but different microscopes lets you view organisms in different ways. For example, a bright field makes you view everything with a bit of a whitish background, and it makes the cilia on your specimen a bit more visible. But some of the better ones, I'd say, would be dark field and phase contrast, because you're able to see a bit more of what's inside of your organism, even better with phase contrast here. And the background's black, so you're just focused completely on that organism. As you can see, the less light is being lost or refracted in higher end microscopy, and compared to the bright field, which kind of goes everywhere. Antibodies, fluorescence antibodies that help even better microscopes. Fluorescence helps you see even better. Microscopy, so specimens are stained with fluor. Three-dimensional images, yes. So you can see your antibodies in the bacterium and how they react. Two-photon microscopy. Long wavelengths, yes. Microscopes use a lot of wavelengths. Help you see. Scanning acoustic microscopy. Electron microscopy. This is the one I really know very well, and I feel like this is one of the best types of microscopes, because it projects electrons, so you're able to capture images of your specimen way better. 100,000 times larger. You can leave a note there. Instead of using glass lenses, an electron microscope uses electromagnetic lenses to focus a beam of electrons onto a specimen. So two types of electron microscopes are the transmission electron microscope and the scanning electron microscope. Here's the transmission. Here's a bit of a view of two-photon microscopy. Scanning acoustic microscopy here. Transmission electron micrograph appears as many lights, dark areas, and the number of electrons absorbed. Transmission electron microscope. Bit of a view of the microscope. Continuing the clinical case. Bacteria pylori. Gonna probably read through that. This is just a skim through, guys, so you can see a bit of the sections and probably go back to this. Scanning electron microscope again. Scan probe microscopy of these various kinds of probes to examine surface of specimen. Scan. Atomic force microscopy. A metal diamond probe is gently forced down into a specimen. Interesting. Yep, that looks like a probe was put into the specimen. So, more objectives for this section, these sections. Staining, smears, to help you understand or learn more about your specimen a bit more. So here's a summary, table of some of the microscopes we went through. Dark field, phase contrast, fluorescence, confocal, 2-photon, and scanning acoustic, transmission, scanning probe, atomic force, some gram staining. Okay, these are stuff you'll probably have to do in the lab if you're taking the lecture. So different kinds of dyes produce, lets you see which kinds of specimens are available, bacteria, antibiotics, or all kinds. Simple stains, aqueous or alcohol solution of a single basic dye. Natural stains, mordant, gram stain, Hans Christian Gram. Hans Christian Gram is the guy who made the gram stain, okay. Dye. Acid fast stain. Oh, this looks like a new technique, or a technique that was new. Strongly only in bacteria that have a waxy material. In their cell wall, so lets you see bacteria better. Here's our continuing of our clinical case number 66, and the resolution to our clinical case also. So it looks like this reading isn't too long. I mean, if we're skimming through it in 15 minutes, I'm sure this will give you guys some confidence to skim through yours. Acid fast bacteria, you can see them. Bit of a check your understanding, some questions to help make sure you understood the material you just read through about your gram staining and your microbes and your microbacterium. Special stains are used to color parts of microorganisms as endospores, flagella, or capsules, so you can see them. Negative staining for capsules. Many microorganisms contain a gelatinous covering called a capsule. Capsule staining is more difficult than other types of stain procedures because capsular materials are water soluble. Okay, looks like these are the capsules and they're trying to stain them so they can view these. You can see the flagellum and the spores. Wow! Okay, a summary of various stains and their uses. Okay, we can see, here's a summary of all the stains we went through. Simple, differential, gram stain, acid fast, and here's the definitions for each of them. If you are curious. Here's an endospore. Spore staining. Endospore is a special, resistant, dormant structure formed within a cell that protects bacterium from adverse environmental conditions. So endospore adds your spore, protects it. No, flagella staining. Okay, this is the type of staining that helps you view the flagellum of the creature. Summary of stains, practice in table 3.3. And we have done it, guys. We were able to get through this whole chapter in under 15 minutes through skimming. Okay, I hope this helps you guys feel more confident about your microbiology and how important skimming can be to give you that sense of confidence, knowing that, if I'm able to skim in about 15 minutes, the reading will probably not take me long because I'll be able to understand what are the important information that I'm reading for and what is probably going to be covered in lecture tomorrow. So I hope you guys really enjoyed this video, and I'll see you in the next one. God bless and have a great day, you guys. Thanks for watching.